Columns are very important. They support the entire building. So here is a plan view showing some columns, and notice that these columns, the end views of these columns, are not drawn to scale. They're drawn big with thick lines so you can for sure see them. And then there's a label on there saying here's what size of column that is. There's another document called a column schedule where we get more information about them. We also want to make sure we give all the dimensions center to center, because that's what all these grid lines are based on. And there are base plates, column base plates at the bottom of the columns, but there are separate drawings for those as well as some information on the column schedules for those. Here's a column schedule for a small building. Now this schedule is created by the designer. It communicates information to the fabricator about what size of steel are they going to use, what length do they cut it, and here's information about what size is the base plate. Here's a column schedule for a little bit bigger building. Notice we have the grid line markers across the top, so we've seen grid B2 before. There's a bunch of them. And what else? Sizes of the columns are given, and down at the bottom here, here are the specs about the base plates. Notice that these are heavy pieces of metal. The splice, the column splice, happens where two pieces of columns have to get attached together. And they might be different sizes, they might be the same sizes. But obviously, if you have a 20-story building, you cannot run one piece of column all the way up there. A column is not made that long, so you have to splice it. Here's the same column schedule again that we saw earlier. And notice that the drafter or the designer has called out the location of the column splice. Looks like every 2 floors there's a splice. And notice that it's about 3 feet above the floor level. So that's interesting. That is much easier to get to for the steel worker to make the splice connections. And then you don't have other stuff that happens in the connection between floors. It doesn't get in the way of that. Think about how heavy the pieces in a building are. So by the time you get to the top of a building, you just have the top floor being supported by the columns. There's not much weight up there. But the floor below that has to support it and another floor, and the floor below that supports 3 floors, and blah, 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 all the way down to the bottom of the building, where those columns at the bottom of the building are carrying very heavy loads. So what we do is we have bigger pieces of steel for the bottom columns, and we get gradually smaller and smaller as we go up. Why not make them all the same size, you ask? Well, we buy steel by the pound. And you've seen some of those pound sizes for wide flanges. 1 foot of steel can rack up a bunch of pounds quickly. So if we can cut down the amount of steel we use, we cut down the cost. So we try to minimize, we try to optimize and use just enough steel but not too much. Here are a couple of column splices. It looks like the one on the left are 2 same size wide flanges. The one on the right are different size wide flanges. And here is a drawing out of the AISC Steel Detailing Manual. Another time when we talked about structural steel shapes, we commented that for a given size of depth, like all 8-inch wide flanges, the inside of the flanges is the same size. And so here is the steel detailing manual saying that. And they are telling the detailer, be careful not to offset, not to make these things off center. Be sure to keep this stuff lined up.